Okay, so thanks everyone for coming. I'm Wei, a first-year PhD student working with Kristen and Jennifer. I'm happy to be here today and share my research about transforming infrastructure resilience from abstract to practice in the context of flood resilience of urban rail transit systems, or the URTS. So, in modern society, the increasingly dependence on the URTS makes it highly connected and complex. This system is particularly vulnerable to unexpected disruptions because a local malfunction could incur cascading failures among the whole network. And this vulnerability has been more clearly exposed under the impacts of climate change, which has increased the frequency and intensity of flash flooding. Flash flooding occurs quickly without much warning, and unfortunately, the current drainage system is inadequate to address it effectively. And this could be especially problematic for the URTS because they are largely located underground and are linked with facilities above ground. The past flooding events have caused operational disruptions, equipment damage, and even threats to people's lives. So, to ensure that the URTS provide constantly safe and reliable services despite flood uncertainty, resilience gains its popularity as the ability to withstand, recover from, and adapt to disruptions. It goes beyond traditional risk management to address a wider range of future uncertainty. However, the application of infrastructure resilience is challenging, because the infrastructure system is essentially a social technical system, and therefore resilience can be interpreted in many different ways. That's why I feel the modern adoption of resilience can be problematic. Through the literature review in my first year, I found that people tend to pick a bit of the meaning and embellish it as resilience, without necessarily being clear on whether resilience is applicable to their context. For example, attaching resilience to traffic congestion modeling doesn't advance the modeling techniques or a deeper understanding of infrastructure resilience. So, to help clear the confusion, my research intends to quantify and improve the flood resilience of urban rail transit systems through complex network modeling. It combines physical network topology and operational passenger travel demands to comprehensively assess the flood resilience of URTS under a wider range of real-like flood disruption scenarios. So in my first year, I used 3 scenarios as a starting point, and the disruption is composed of node failures and edge failures, and they are generated based on location-specific flood exposure of stations and tracks. And taking them together, resilience is assessed based on the system performance-based resilience triangle model. And the number of satisfied passenger journeys is used as the indicator of system performance. And the initial resilience curve shows how the system function is affected and recovered during the disruption. And we can see that maximally 15% of the passenger journeys can't be met, and this is unacceptable in practice. So what kind of intervention strategies could be adopted to improve the flood resilience? Further work will adopt machine learning to test the efficacy of such strategies under more flood scenarios, such as what if the Thames barrier fails, what will happen in London? So that's basically all about my first year. Hopefully this research could contribute to a better understanding of infrastructure resilience, an actionable pathway for URTS to effectively cope with flood disruptions, and the improvement of the current methodology on resilience modeling. And that's basically all about my presentation. If you are interested in any details or any collaboration, please drop me an email, and I'm very happy to have a chat. Thank you.
Thank you.